I accidentally ended the last video instead of pausing the last video. So if you do watch these videos, the last two examples won't be on the first one. You have to go to the second video. My bad. Push on button. So if you look at E, we've got a fraction. Right? My rule is numbers go with numbers and letters go with letters. We like to simplify things first. When I go to simplify this, the 8 and the 4, that means they go together. 8 divided by 4 equals 2. This one's a little bit tricky because then you have a to the negative 5 and b to the negative 3. Those are different letters, right? So when we say letters go with letters, only the same letter goes with the same letter. These two exponents cannot be subtracted from each other because they're different letters. So they actually stay the way they are. They stay as a to the negative 5 and b to the negative 3. It's the first trick to that question that makes it harder than the others we've done. Because you've got to remember that different letters don't combine. Awesome. Now that you've simplified, you have to deal with our rule that says you can't have negative exponents in your final answer, right? You have to have positive exponents. Looking at this, it's important to identify which powers have negative exponents. This power has a negative exponent. This power has a negative exponent. The 2 does not have a negative exponent, right? It's not part of either of the powers. Only those things with negative exponents are going to move. So a to the negative 5 is going to move to the bottom. B to the negative 3 is going to move to the top. The 2 stays on the top. My final answer would be 2 times b to the power of positive 3. I think the 2 stayed on the top. The b came from the bottom to the top, and now it's a positive exponent. The a to the negative 5 had a negative exponent. We moved it to the bottom of the fraction. Now it's a positive exponent. So it's a to the power. That's probably about as hard as it'll get on a test. You might get one question that's kind of a little bit more chunky than that, but that's a hard one. Right? It follows a couple different rules. Awesome. Let's look at F. Again, there's multiple ways to tackle F. The way I would do it is I would deal with any exponent laws I could to start things off. So if I'm looking at this, I have a negative 2 exponent here. It's outside the brackets. I would like to distribute it into the brackets. When I do that, that gives me 5 to the negative 2, p to the negative 2. Divided by 5, and then q to the power of 4. That's how I would like to deal. I deal with it by distributing in the exponent, and then I start to do anything else I can. Looking at this, coefficients go with coefficients. Looking at this thing, I have 5 to the negative 2 divided by 5. There's 2 different ways to do this. Right? You could put it in your calculator, get a decimal, change it to a fraction, and then get 1 over 5 is what you end up with. And that would work just fine. Another way to do it is to use your exponent rules. I have negative 2 here, and I have 1 on the bottom. Negative 2 minus 1 would give me 5 to the power of negative 3 on top. That's negative 2 minus 1, because the exponents are negative 2 and 1. My other letters can't be combined because they're different. So I still have p to the negative 2, and I still have q to the power of 4. That is me distributing in the exponent and then simplifying anything I could. Numbers with numbers, letters with letters. My last step is to get rid of any negative exponents that I have. In this case, I have 5 to the negative 3. That needs to move to the bottom because it was a negative exponent. I have p to the negative 2. That needs to move because it's a negative exponent. The q to the power of 4 stays on the bottom because it was a positive exponent. My answer would be 1 on top, 5 to the power of 3 on the bottom, q to the power of 4 on the bottom, p to the power of 2 on the bottom. If you wrote that as your final answer, I would 100% accept it and I'd give you full marks for it. Does anybody have any suggestions on how that could be a different answer but still the right answer? Yeah, calculate the 5 to the power of 3. You could put that part only in your calculator and simplify it. So you could put 5 to the power of 3 in your calculator, you would get 125. So if your final answer was written like this, if your final answer was written like this, 1 divided by 125 Q4 P2, that would also be a perfect answer. Right, both answers would work just fine. All right. The next little things are just kind of trivial. So class example 4 we're not going to look at. Class example 5 we're not going to look at right now. This stuff right here. Actually, no, let's do those examples first before we talk. Let's look at class example 4. Because that's a crazy example. Okay? Like when I said you might get a question that's way harder than that, this would be an example of that. This question is extremely difficult. The way I would tackle it is I would break this question into probably 2 different chunks. I would try to simplify just this first. That's a big fraction. Then I would rewrite this divided by whatever my answer is as a fraction again and then try to do the question. So looking at this, let's just try to simplify that thing. I circled in the blue. We'll start there. When I do that, we say numbers go with numbers, letters go with letters. My numbers, I have a 15 on the top. I have no numbers on the bottom. That means I still have 15 on the top. Next letter, I have x to the power of 8 on the top, x to the power of 5 on the bottom. 8 minus 5 is 3. That gives me x to the power of 3. Remember, when you use the exponent rules, it always goes to the top, even if it's negative. Our next thing that we have y to the 3. Whoa, that didn't work. We have y to the 3, y to the negative 3. If you were to use your exponent rules, 3 minus negative 3 would give me y to the power of 6. That green's a little hard to see, I apologize. The last one we have is z to the negative 1, z to the negative 2. If you go negative 1 minus 2, you get z to the negative 3. That means this entire thing I've circled in the blue simplifies to be just that. And that became that. Now we can look at the original question and try to combine everything all together. So I've got this big thing here divided by this blue thing there. I like to write divide by as a fraction. I find it easier to work with. So I'm going to rewrite this. It'll be 5 x to the 3, y to the negative 8, z to the negative 2. Divided by 15 x to the 3, y to the 6, z to the negative 3. My apologies if the lines keep connecting to each other. It's this new program, it doesn't like the smartboard very much. The y's like keep connecting on the top and the 3's and the negative signs connect. Makes it look a little messy. Which doesn't help my already messy writing. Awesome. So I took this, I rewrote it as a fraction because I just find that easier to work with. All right, you technically don't have to do that step. Now I combine numbers with numbers, letters with letters. Looking at this guy, 5 and 15. You can divide both of those by 5, which would leave you with 1 divided by 3, or you can put in your calculator 5 divided by 15, and then go math, and then go frac, and it'll become 1 over 3. Right? So 1 goes on the top, 3 goes on the bottom. Fantastic. Now we move on to our next letters. We have x to the 3 divided by x to the 3. 3 minus 3 is 0. Anything to the power of 0 equals 1, so we don't write it. What you've learned in the past is that these cancel out. Right? And that's technically what you get. And if you have 3 on the top, 3 on the bottom, that means you have x to the power of 0. You have 0 left, so you don't write them anymore. Awesome. Next letter. We have y to the negative 8 divided by y to the 6. Negative 8 minus 6 would give me y to the negative 14. Right, negative 8 minus 6. Our last one, we have z to the negative 2 divided by z to the negative 3. Negative 2 minus negative 3 would give me z to the power of 1. You typically don't have to write the 1. I'm going to write it just so you see it. Awesome. So that big crazy thing that we started with simplified out actually pretty decently. And you don't have that much left. That would be a really good answer. You're just missing one thing. The one thing we're missing is that you can't have negative exponents. This does have a negative exponent. We have, I don't know if you can see that. So this weird magenta. We have y to the negative 14. You have a negative exponent on one of your powers. That is not allowed. You need to take that negative power and move it. Everything else stays where it is. So my final answer would be z to the power of 1 on the top. If you didn't put the 1 as an exponent, that's perfect. That's fine. Notice that I'm not writing the 1 in front either. We don't write 1 times something. If you did, you're not wrong. You just don't need to do it. On the bottom, I have the 3. It's still there. It hasn't moved. I have the y to the negative 14 did move, and now it's positive. My final answer is z divided by 3 times y to the power of 14. That's a crazy question. Right? That would be easily the hardest question on a test. I'll give it to you. Right? You probably won't see something that ridiculous. But if you do see something like that in an assignment question or something, and you can get it right, then you are good with your exponent laws. Right? That's kind of the way to look at it. Like it's like the upper echelon. If you can do that, you should be set. Cool. We'll talk about number 5 because it's a good talking point. It says explain why this thing doesn't equal. That's what that means. So it doesn't equal this thing. If you look, it looks like what they did was we have 2p to the negative 3. Negative exponent means move it to the bottom. I get 1 divided by 2p3. Right? That looks like what they did, and that looks like everything I just talked about, so it seems right. But it's not right. They've done something wrong, something little. Who can recognize what they did wrong here?
There's a positive exponent for the 2, so
Exactly. There's a positive exponent for the 2. And the reason we want to show this question is because that is one of the biggest mistakes that we end up with. Let's say with red. Understand what has an exponent that's negative and what has an exponent that's positive. This 2 is to the power of 1. The p is to the power of negative 3. Only the negative power. Ooh, you see that blue? No, it's everybody. Yes, everybody. No. better color. The nice dark blue. Only the p had a negative exponent, so only it should move to the bottom. The 2 should stay on the top. That's what it should have been. It says explain why. The explanation would be the 2 has a positive exponent. It should not have moved. Awesome. We're not going to really look at this. All it tells you is that if you have a fraction with a negative exponent, then you can flip the fraction and change it to a positive exponent. That's supposed to be a 4, not a 9. That's not a rule that you need to know. It could be handy from time to time to make things go quicker. But if you didn't know that rule and you just followed our regular rule of distribute this in and then deal with it, that would work the exact same way. So that's why I don't really deal with this. It just muddies the water for most people. Okay, so I wouldn't worry about this side at all. All right, you now have questions 1 to 17. That's tons of exponent questions to work on. And I think we only have one lesson left on exponent.